Okay, welcome back. In this episode, we're gonna calculate the normals of a arbitrary polygon. And for this, we're gonna change some things in our simulation class. It's not that much. Just gonna remove this part of the comment and create a rectangle again. Then I'm gonna comment these things out. And then I want to draw the test rect. So I'm gonna replace the circle A with the test rectangle. Yeah, we can leave that there. That's not a problem. But I want to replace this test circle B with the test rectangle. So I'm gonna do my little trick with holding Shift and Alt on Windows and drawing kind of a rectangle, what a coincidence, and setting it like this. Okay, so let's make sure everything still works. There we go, we have our rectangle and we can move it still with the right arrow keys. Okay. Good. Then let's jump back to the code. So now we are calculating the normals of the rectangle. For that, I go to the math helper class, and under the rotate around point method, I will create a new method called static calc normals for calculating normals. And this will get the vertices. Then I'm going to create a variable called normals, and this is going to be a empty array. And then I'm going to loop through every vertice. Okay. And then I will I will calculate the direction from the current vertice to the next vertice. I'm going to do this like this. Direction is equal to subtract the note. To get the direction from vertice A to vertice B, we need to subtract the next one. We need to subtract the vertice A from the next one. So I need to use the next vertice first, and then I'm going to use the vertice of the current element of the array. So here basically I need to do something like this, and then I have the right direction. But this will not work because we are gonna run into an error. Arrow and error are kinda difficult to pronounce for me. Well, anyway, we need to use our method we did earlier, and that's the called index method, to not run into index out of bounds exceptions or like that. So I'm gonna write I plus 1 because we want to have this index, and then I say vertices.length, and there we go. Then we can normalize the direction, and then I'm gonna push I'm gonna call the push method But before that, of course, we need to calculate the normal. So I'm gonna say let normal is equal to direction dot get normal. Just make sure I did that right. Get normal, there we go, yeah, all right. And then I'm gonna push this one. Okay, and then I can return the normals. All right, so that should be it. I'm just checking if everything's right. Looks good so far. Okay. And then I'm gonna go to the polygon class because that's the class we're gonna use that. And after the calculation of the centroid, I'm gonna say list of normals is equal to math helper calc normals. And also I give it the vertices. That's it for this one. And then I'm gonna override a method, and that's the rotate method. Because the reason behind that is we need to rotate the normals too. That sounds pretty difficult to rotate a direction vector. So what I'm gonna do is, well, I'm not rotating the direction vectors, you know, the normals. What I'm gonna do is, of course, first call super rotate, and then I'm just call this normals equals math helper calc normals again. And that's it. The reason is when I call super.rotate in the shape class, I think, all the vertices are rotated and the vertice positions are updated. And then when I call calc normals again, the normals are simply calculated again from the new vertex position. So I don't need to rotate the normals by using another method, for example. It's just a bit handy, but that's probably one thing we can optimize maybe. But yeah, I'm not going to do that. It's just simpler and it does work too. Pretty good actually. Okay, and then I'm not quite sure if I did this already. Yeah, I did this. Okay, now I just looked about drawing the center point. Yeah, now I want to draw the normals actually we calculated. And for this, I need to iterate through every vertice or every normal. It's not important which one you want, which one you use, because the polygon will have the same amount of vertices, the same amount of normals, like the vertices. It's always going to be the same amount. So you could use this dot vertice length or this dot normals dot length. Doesn't matter. I'm going to use this dot normals dot length, but you could also use this dot vertices dot length. Okay, then to draw them, we want to use the draw line function of the draw utils class. And for this, we need to have a start position and an end position. And the start position, I want to have the start position between the vertex points, the middle of the vertex points. And for this, I first need the direction vector between the vertices. And this is going to be, this is not vertices. from the next one, the next vertex minus the current one. And the next, again, I need to call the index method. So mathhelper.index I plus 1, the next vertex, and I need to also pass the vertices.length because it's gonna make sure I'm not running out of the indices of the array. That I get that index out of bounds exception. I don't want that. And then when I have the direction, I can calculate the start position. And this is pretty easy. I just say let center. So this is gonna be our start position. I'm gonna add to the current vertex position the direction vector, but not the whole direction vector. If I'm gonna say something like this, then I'm gonna end up at the next vertex. So I just want the half of it, okay? So I'm gonna say scale direction with a number of 0.5. So with half of it. And then I'm gonna end up in the middle between two vertices. Yeah, and then I can already say draw utils, draw line. But of course I need to have a end position. So I'm gonna calculate it too. And I'm gonna call this, I'm just gonna call this end. And this is going to be again a summation of the center point we calculated. And then I want to go out of the polygon. And for this, we can use this dot normals because they are already perpendicular to our direction. And if I'm going to use this one, we're not going to see that much because this dot normals is already normalized. That means the length of this vector is going to have just a 1, 1 pixel. And that's not enough to see anything, or at least see more. No, you don't see that line really good then. So I'm just gonna scale that by not changing the value of this array. I'm just gonna use that normal, scale it by, let's say 15, but I'm not gonna change the actual value in the array. And then I can say finally draw utils, the draw line. I'm gonna say from the start, that's gonna be the center, then to the end, and then with a color of, let's say, green. And that should be it. Okay. So let's try this. Hopefully it works. There we go, it does work. Of course our rectangle is now green, but that's not that important. Now the important question, are our normals rotated correctly when I rotate the shape? So, oh yeah, it doesn't look like this. This is the example. Well, that's the result if you don't rotate the shape correctly. Let's see what's the reason behind that. Maybe I did something wrong by drawing. Oh, and I thought I also get some errors. I didn't notice that. Vertices are not defined. Polygon line 11. Ah, yeah, okay. I need to say, of course, I need to say list of vertices. This is going to happen a lot of other times too. It's gonna happen. But it should work now. And that's why if there's any error first happening in a method, then the whole method won't work. So that's why the vertices or the normals are not calculated correctly when I rotate the shape. So, okay, make sure you saved. Then let's rotate that again. Let's try again. And there you go. Our normals are calculated correctly. Awesome. And now we should have everything we need to do probably the most complex, one of the most complex things in the simulation in our engine, and that's the polygon versus polygon collision detection. And after that, the circle versus polygon collision detection. These two are gonna be one of, yeah, they are like a summit of a mountain. You know, if you have that, then you're pretty far. And then the next one is going to be the resolving collisions, because that's the point. Mostly some or everything is just breaking apart, and you don't know what's happening. But I'm sure we get this. Okay, then see you in the next episode when we're gonna implement our polygon versus polygon collision detection. Have a nice day and see you then.